In this video, you'll be learning how to use the weather wave. The weather wave is a method used to determine how compounds look with their valence electrons surrounding them, the Lewis-Stock diagram. We will first have an explanation of what the weather wave is about, then we will teach the steps of the weather wave so that we can solve exam problems later. In this video, we'll show 3 examples and we'll exhibit the 3 different types of bonds: single, double, and triple. Once the problems are solved, you will then see how the Lewis-Stock structure is made. You will also see where to place single, double, or triple bonds within the molecule. And now on to the steps.
So these are one of the steps for weather wave. Now we do have 2 parts that consist of before and after. First, we'll do the before part, as that is usually done first in the weather wave. So it's written out, and we have the problem of NH3. Now, the before section is written like this. We have this compound, NH3, and we only have 2 elements in it. So we have 1 blank for nitrogen, plus another blank for hydrogen. Now it equals something. So, important step that we have to do is find the structure of that compound. So because of the subscript that we have in hydrogen, it will be a 3 times 3. So that's one of the first steps you can do. We also have to find out that most elements have or want to reach 8 valence electrons. Exceptions to that include helium and hydrogen, which could only reach up to 2. Now we know that we have a hydrogen in here, so that will only be up to 2. And we look at the periodic table in the columns to find how many valence electrons each element has. The periodic table consists of 1 to 18 columns. Now the second number of that column is the amount of valence electrons it contains. Now we know that nitrogen, being the column that it's located in, has 5 valence electrons. Hydrogen only has 1. Now, because of its subscript written here, it's important that we always multiply first during the before section in weather wave. Because of this, multiplication is the highest order in math and is the most important. So it'll be written out as 2 blanks, nitrogen, hydrogen, 3 on top, and 5. So now we can add, and it equals 8. So this is the before section. And now we're ready for the after part.
And after step of the weather wave, the first thing you'll do is illustrate your after. Then you will list your elements that you got from the before column. Once you've done that, the first thing you do, since the subscript of NH3 is 3, you will put it beside hydrogen, because that's part of the octet rule. It's part of the octet rule. After that, you have to multiply each column by 2. Keep in mind that if it's over 8, you must keep it at 8. That's part of the octet rule. So 5 times 2 is 10, but you have to keep it at 8. It can't, the valence electron can't be above 8. Boom. The next step you'll do is multiply hydrogen times 3, which will be 6, and do 8 plus 6, which would be 14. Once you've done that, you subtract the after total, subtract the after total value to the before total value, which will give you 6 bonds. Once you solve it, you always have to divide by 2. And that will leave you with 3 bonds. Now on to the first example.
Alright, so the first example in the wetter way is a single bond. For this example, I'll be using H2O. So you start with the before. You use 2 spaces for each of the elements in the compound. One for H and one for O. You add these together like always, no matter what kind of problem you're doing. For H, we're going to keep going. That's a coon in the background. So, for H, we'll multiply it by 2, because in the compound you get 2 H's. Now, to fill in the blanks, you have to use the valence electrons from each of the elements. Valence electron for H is 1. Valence electrons for oxygen is 6. Now, you set up your equation, now you calculate. You multiply first and then add. 1 times 2 is 2, 2 plus 6 is 8. Now you're ready to start the after. Set it up the exact same way. 2 spaces at both H, at both O. The 2 carries with the H because H2O does not change regardless. So bring up the 2. And now this is where it gets different. You have to multiply each valence electron from before by 2 to be stable. Valence electrons cannot exceed 8. If the number you multiply by 2 exceeds 8, then stay at 8. So you multiply both of them. 1 times 2 is 2, so the after for H will be 2. 6 times 2 is 12. Since it's greater than 8, you'll stay at 8 on oxygen for the after. Now you calculate this problem the exact same way you did the bottom. 2 times 2 is 4, plus 8 equals 12. So now that you've got both tables set up, you have to subtract the before from the after. 12 minus 8 equals 4. Once you get this number, you must divide by 2. That is a constant rule for any wetter way problem. 4 divided by 2 is 2. Once you get your final answer, this number will give you the number of bonds you need once you draw out the actual diagram. So when you take H2O and you draw it out, O will go in the middle because that's the least amount of elements. And H will go on either side. From the table, we got that H only needs 2 to be stable. Each bond counts as 2. Both H's are stable. O only has 4, so you need to add 2 pairs of lone pairs to make it to 8. 1 on the top and 1 on the bottom. And after you do this, that is your final answer. And this is how you do a single bond for the wetter way.
Alright, this is an example of a double bond. A double bond will be CO2, which is carbon dioxide. Alright, so you start off with your after on the top and your before on the bottom. Draw 2 lines. 2 lines for the amount of elements that you got. One will be carbon, the other one will be oxygen. Same for the after. Carbon has 4 valence electrons. Oxygen has 6. And you would multiply by 2 because you have multiply by 2 because it's 2 oxygens. So 6 times 2 is 12, plus 4 equals 16. And up here you do the same thing, 1 for carbon, the other one for oxygen. You multiply by 2 here, because you're trying to get it stable, but it can only exceed 8. So 4 times 2 is 8. And 6 times 2 is 12, but it can only go to 8. So you can put 8, and it'll be times 2, of course, because both it's 2 oxygens. So 16 plus 8 is 24. Now you do 24 minus 16, and you get 8. Then you divide by 2, and you get 4. So 4 tells you how many bonds. And you draw this by putting carbon in the middle, 2 oxygens on each side. You got 4 bonds. So you put 2 on each side. Each bond represents 2 electrons. And each of them, they both want 8. So carbon is filled with 2, 4, 6, 8. But oxygen isn't. So therefore you have to draw lone pairs. Lone pairs are furthest away from the bonds. And they're always in pairs. So you draw them like that. And boom, that is your diagram, and this is how you do wet array. I'm the bomb dog.
Alright, so I'm going to show you an example of a triple bond. So, like the previous ones, you start off with your before. Alright. You have one for each one. So I'm showing you CO, carbon monoxide. Have a spot for a C, you have a spot for O. You look at the periodic table. Carbon has 4 valence electrons. And oxygen has 6. You want to add those together. You get 10. Then you want to go to your after. Same thing, 2 spots. Yeah. Alright, and so you multiply both by 2. 4 times 2 equals 8. And 6 times 2 equals 12, but because of the octet rule, you keep it at 8. And then 8 plus 8 equals 16. After that, you want to subtract your before from your after. So 16 minus 10 equals 6. And you always divide by 2 after that, which equals 3. And this lets you know that there's a triple bond. Show you what that looks like. See, you have O. Triple bond would be here. And there's 2 lone pairs on each. And that's how you do a triple bond.
I like eating dessert first. So not food coloring.
Yo, squeeze it.
Do you have something on the counter so you don't have to clean this up?
No, I mean, we got paper towels. Yeah.
If you put something down ahead of time, all you have to do is pick that up. But you all are gonna do it the dumb way. So why should I?
It's still gonna work.
All right. Now what?
You wanna add blue?
No, it'll just turn black.
Yeah.
Now what? This soap?
It's all going in there together, it doesn't matter. So
Well, I didn't know what was going in there in the first place.
this stuff I gave you.
Oh yeah, pass me the that junk. Yeah. How much that stuff we put in there? Can I put all of it? Right, that would be dope. Good catch. How much you put in here?
This is not gonna end well.
Go ahead, do it.
Just like ammonia.
Oh, you got that on camera? Don't do that. Watch a music video.
Waft the chemicals? Waft it, Brian.
It's still gonna snort it.
What's the Bayless electron?
Go ahead.
It's up under the period.
It's the-
So,
Is it like the 1, 2, 3, 4, 5, 6, 7, 8, or
so
negative?
for this one, that's the one here. If it's in the first group, all of these have one valence electron. All of these have two. The metals don't. It depends on
So
what
can you
metal
point
bond
to
it's
that
at.
phone?
All of these have three.
It's
all of these have
alive.
4, 5, 6, 7.
Wait, I thought we needed disso for it.
I think we do.
Is it gonna stop?
Oh, wait. I thought we needed disso.
Oh.
Ah!
Oh.
That's not like the one we see. That's right.
Ours is cooler.
Oh God, things hard.
I should throw a match.
Looks like
over there.
soap.
You should throw what?
We can light it on fire?
Yeah, but we're not.
It's already hot. But
Go to this at home.
I wanna go ahead.
Please don't do this at home.
too late. I actually did it over one
I
weekend.
might wanna. No, I'm good.
Smells good.
Yeah.
Danny, put that on the screen. Do this.
Put one on the screen.
Do this at home.
Don't do this at home. Seriously, we're professionals. Clearly.
This is clearly not professionally done.
Yeah. So, any more tutorials or anything, add me on Snapchat, KillerBeat2017. No spaces, no underscores. It's all lowercase.
And me.
Yeah, hit up Mazen because we're a collab.
This is actually this.
Like no homo, but we're a collab. So it's like 704-840-38.
Oh, God.
Want to make sure you got a lot of bubbles and you want your whole hand to be wet. You want paper towels?
It's actually fine. Here we go. Can do it again. I'm afraid this is not as many bubbles.
There you go. Give it to the souvenir.
You look like yourself.
Me.
Yo, dude, feels all warm now.
Oh, God, that was hot. It went out with the bubbles. There you go.
So don't continue to air.
You gotta do this?
Yeah.
Yeah, you need to,
Yeah, also my bubbles in it.
put them out of the.
Wendy, let me light you on fire, bro.
Hold on.
This is what happens when I put my mixtape in Wendy's hands. My mixtape! Ah! My turn. More bubbles.
Weak, bitch.
Okay, so we'll just put the match in the jug.
I like that.
She can't even let the match.
Chill out.